Welcome to the Deep Dive. Today we're plunging into, well, what many consider the next big leap in enterprise technology. If you ever wondered how big companies actually move from those experimental AI chatbots we hear about to really robust production-ready systems, it's definitely less about magic and, more about solid engineering, especially when you're dealing with massive amounts of internal data. So our deep dive today is all about LLM and generative AI enablement on Databricks Lakehouse. We're breaking down a really fascinating technical document from Sri Sivakumar Ramar, dated July 14, 2025. And this document's not just a tech guide, right? It kind of reveals how companies can achieve enterprise-grade large language model, LLM, and generative AI capabilities securely and at scale. It's basically the blueprint for making advanced AI actually work in big business.
Exactly. And our mission today, really, for you, the listener, is to pull out the most important nuggets from this document. Think of it as your shortcut, a way to grasp the core components, the processes involved in bringing this enterprise AI to life. Without getting totally bogged down in every single technical detail, we're here to help you connect those dots, see the bigger picture.
Okay, sounds good. Let's start at the beginning then.
Yeah.
Before we dive into the technical bits and pieces. Why? Why are enterprises so keen on implementing LLMs and GenAI with a platform like Databricks Lakehouse? What's the fundamental business driver here?
Well, what's interesting is that the overarching objective is actually pretty straightforward. It's stated as enable enterprise-grade LLM and GenAI capabilities. But what that really means is empowering their data teams, giving them the tools to build, fine-tune, serve, and monitor generative AI models securely and at scale. The core insight, I think, is that the real challenge isn't just having AI models. It's integrating them securely, scalably, making them governable within the existing business operations. That's what this enablement is really all about.
That's a critical distinction. So we're not just talking abstract concepts. What are some of the actual tangible problems these businesses are trying to solve? What are the applications we're seeing in the real world?
Precisely. And the document highlights several specific use cases that really bring this home. We're talking about things like contextual chatbots with enterprise data. So imagine an HR bot that actually understands your company's specific policies because it's trained on your data.
Okay, that sounds incredibly useful.
Right. Then there's intelligent document summarization. Think about legal teams, research departments, just drowning in text. This helps them distill key info quickly. Code generation and data pipeline assistance, that's a huge one for developers, data engineers. Speeds things up dramatically. And finally, semantic search and recommendations. So finding information based on meaning, not just keywords, much more intuitive.
That's a really powerful set of capabilities. It sounds like it's less about just consumer apps and more about unlocking, interacting with the company's own knowledge, turning static documents into something active. Which of those, maybe from your perspective, presents the biggest technical hurdle for companies trying to do this themselves? And how does something like Databricks aim to help with that specific hurdle?
That's a great question. Often the biggest hurdle is stitching all these different pieces together seamlessly. The data, the models, the security, the governance, it's complex. And that leads us perfectly into the architecture, actually.
Right. So what does this architecture look like? If you're building these sophisticated AI systems, what are the key layers, the components you absolutely need, especially to tackle those integration challenges you mentioned?
Okay, so if we connect this to the bigger picture, it's about having a kind of comprehensive structure, one that handles the whole AI model life cycle, right?
Right.
From raw data to deployed application. The document outlines 5 core architectural layer components. First, there's the data layer. This is built on Delta Lake, that's Databricks' open format for reliable data storage, handles structured, unstructured data. Crucially, it also includes vector stores, things like ChromaDB, Milvus, and now Databricks has its own native vector search.
And those vector stores, they're for the semantic search part, right? Finding by meaning.
Exactly. They let the AI quickly find relevant info based on meaning, very different from keyword search. And underpinning all that data stuff is Unity Catalog.
Unity Catalog, we hear that a lot. What's its main role here?
It's vital, primarily for data governance. Think data quality, lineage, and especially secure access control, making sure the right people access the right data. Then, moving up, you have the model layer. This is where the brains are. Your pre-trained LLMs, OpenAI, Mosaic ML, whoever, plus open source models from Hugging Face. And importantly, fine-tuned models, using techniques like LoRa or PEFT.
LoRa and PEF. Can you quickly unpack those?
Sure. LoRa is low-rank adaptation. PEFT is parameter-efficient fine-tuning. Basically, they're smart ways to adapt these huge pre-trained models to your specific company data without needing like enormous compute power for a full retraining. Much more efficient. Next up, the compute layer. This is the muscle. Databricks ML runtime leveraging GPU clusters for the heavy training and serverless model serving for efficient, scalable deployment. Then the application layer. This is how you actually use the models. Standard API access using REST, deep integration with frameworks like LangChain, which is really popular for building complex AI workflows, and GenAI-enabled notebooks for development. And finally, tying it all together, the monitoring and governance layer. This uses MLflow, that's machine learning operations for tracking experiments, model performance dashboards, and again, Unity Catalog pops up here too, ensuring everything's tracked, compliant, performing as expected.
Wow, that really paints a picture of a very integrated stack. It definitely sounds like having all those specialized tools and the infrastructure kind of pre-integrated is a huge advantage, but it does sound like a lot of moving parts. Where do you usually see companies stumble when they try to stitch these layers together themselves, maybe before adopting an integrated platform?
Yeah, often it's the handoffs, the seams between the layers, like moving a fine-tuned model from a development notebook into secure production-level serving. That can be tricky. Or ensuring that the vector store is always up to date with the latest enterprise data and, crucially, governed by the same access policies as your main data lake. Those are the friction points these integrated platforms really aim to smooth out.
Makes sense. Okay, let's dive a bit deeper then into the specific features. What are the core capabilities on the Databricks Lakehouse that make all of this enablement actually possible and help smooth out those friction points?
Right, so there's a pretty robust set of key features designed to streamline the whole process. You get model access sort of out of the box to popular models like from Hugging Face and Mosaic AI, makes it easier to get started. There's strong fine-tuning support using those efficient techniques we talked about, LoRa and PEFT, and it's all integrated with MLflow, so you can track your experiments, ensure reproducibility. That's huge. For actually serving the models once they're ready, inference serving is handled by Databricks Model Serving, designed for scalability and reliability.
And the vector search, you mentioned that's native now.
Yeah, that's a big one. Vector search is native, highly optimized, makes integrating that semantic search capability much simpler. Then, for building the actual intelligent applications, they offer powerful GenAI pipelines. These support prompt engineering, crafting the right questions for the AI and Retrieval-Augmented Generation, or RVU.
RAG. That's the technique to stop the AI making things up, right? Grounding it in real data.
Exactly. It's essential for making LLMs reliable with your company's private data, prevents those hallucinations. Plus, there's deep LangChain integration, which simplifies building those complex LLM workflows within Databricks. And finally, comprehensive MLOps integration via MLflow, tracking, deployment, ongoing monitoring, the whole lifecycle management.
Okay, so we've covered the why, the what, and now some of the how with these features, but let's visualize it. How does the data actually flow through this whole system? Can you walk us through that journey, maybe from raw information to the final intelligent application?
Absolutely. Visualizing the flow helps a lot. The document has a clear data flow diagram. It starts, naturally, with your enterprise data, often raw, maybe unstructured documents, database entries, logs, whatever. This flows into Delta Lake and Vector Store. Here, the raw info is ingested, processed, may be cleaned, and stored reliably in Delta Lake. And crucially, representations of your text data, those embeddings often land in the Vector Store, ready for that semantic search.
Okay, data's prepped and stored. What's next?
From there, it moves into LLM fine-tuning in Databricks. This is where you take a base LLM and train it further on your specific enterprise data, tailoring it for your tasks. Once you have that fine-tuned model, it gets registered in the MLflow model registry. Think of this as a central library for all your trained models, managing versions, stages vital for governance and reproducibility.
Got it. Model is trained and cataloged. How does it get used?
Right. From the registry, it's pushed to model serving. This makes the model available as a scalable API endpoint. And finally, that endpoint is consumed by your business application's API. Could be a chatbot, a summarization tool, an internal search engine, you name it. That's where the end user value happens.
This is where it really starts to click, I think, where you get those aha moments. Let's make it super concrete. Imagine you're building that internal AI system we talked about, maybe to answer questions about company compliance policies. The document actually walks through a 6-step process, complete with sample inputs and outputs. Let's unpack that practical example. This should really clarify things.
Yeah, this specific example is great for seeing the whole thing end to end. Step 1 is data preparation. Okay, so you start with your raw enterprise documents, maybe PDFs, Word docs stored in Delta Lake. Let's say one says, our enterprise complies with ISO 27301, focusing on information security management. The process involves pre-processing this, cleaning it up, maybe converting it to plain text, like, our enterprise complies with ISO 27301 information security management. This clean text then gets stored, maybe in a Delta table with a specific column, say, clean text, ready for the AI.
Okay, makes sense. Clean text ready.
Step 2, create embeddings and vector store. Now, you take that clean text, you use an embedding model the doc mentions, sentence transformer sol ML6 v2 from Hugging Face as an example. This model turns the text into vectorized embeddings. Those are just lists of numbers, basically, that capture the meaning. These allow the system to find similar concepts, even if the words aren't identical, and these embeddings, they get stored in your vector store, like ChromaDB or the Databricks vector search.
So the meaning is now stored and searchable. What's step 3?
Step 3 is fine-tune LLM. Okay, here you grab a pre-trained large language model, maybe Mosaic's MPT-7B or Meta's Llama 3, something powerful, and you fine-tune it using a dataset specifically created for your task. For our compliance example, this dataset might have pairs of prompts like summarize the compliance policy along with the relevant chunks of your actual compliance documents as the context. The output of this step is your fine-tuned LLM, now specialized for understanding and talking about your compliance stuff.
Right, specialized for the task.
Step 4. Register model in MLflow. You've got your trained, fine-tuned model. Now you register it in MLflow. This is super important. It logs the model artifact, assigns it a version, like Model 1. This gives you lineage, lets you track experiments, manage the model lifecycle properly. You know exactly what model is running where.
Okay, model's trained, registered, time to deploy.
Exactly. Step 5 is deploy model with Databricks model serving. You take that registered model version and deploy it. This essentially creates a scalable web service, an endpoint. You can then interact with it via an API call. The example shows a simple REST API call. Send it a JSON payload, like prompt, summarize ISO policy. The deployed model processes this and sends back an inference response, maybe another JSON-like response. The company follows ISO 27001 guidelines for data protection and risk management.
So now it's live and responding. What's the final step?
Step 6, build RAG pipeline with LangChain. This pulls it all together into a useful application. You use a framework like LangChain to connect the user interface, the deployed model endpoint, and that vector store we created earlier. So a user types a query into a chatbot, perhaps. Explain our ISO compliance scope. LangChain takes that query, first uses the vector store to find the most relevant text chunks from your compliance documents based on meaning. Then it sends the user's query plus those retrieved chunks to your fine-tuned LLM endpoint. The LLM uses that specific relevant context to generate a grounded RAG answer. The output might be a text response like, our ISO 27001 compliance includes data protection, access control, and risk management across our internal systems. Much more accurate than just asking the base LLM.
That end-to-end flow makes it crystal clear. So you've got the input query coming in, the vector search retrieves, the relevant context for your own data. The specialized LLM generates a response using that context, and then that accurate answer is output to the user. It really demystifies what could seem like a black box.
Okay, now let's pivot a bit to the real-world side of things. Deploying these models, what are the key things enterprises really need to consider when putting these powerful systems into production? Beyond just the technical steps, what are the practicalities?
Right, the deployment considerations are absolutely critical for making this work reliably and securely in an enterprise setting. For compute, the document stresses. Use Databricks ML runtime with TPUs. These models are hungry for processing power, especially during fine-tuning and even for fast inference. GPUs are pretty much essential. Security is obviously paramount. The key here is data lineage and access via Unity Catalog. You need fine-grained control over who accesses what data, and you need to track how data is used by the models. Unity Catalog is positioned as the single source of truth for that governance. Makes sense. What else?
Managing the models themselves. Use MLflow for model versioning. You need to track different versions, be able to roll back if something goes wrong, compare performance. MLflow is central to that. Then there's inference scaling. Your usage might spike. So leveraging serverless endpoints or auto-scaling clusters is important to handle varying demand efficiently without over-provisioning, and controlling costs. And finally, you can't just deploy and forget. Continuous monitoring is key, using MLflow dashboards and alerts to track model performance, accuracy, latency, potential drift, ensuring it's still doing its job effectively over time.
That really highlights the operational side. It's not just build it, but run it, manage it, secure it, which naturally raises the question of risks. Because, let's be honest, no advanced tech comes without challenges or potential downsides. What are the common risks involved when implementing this kind of AI in a large organization, and how does this Databricks approach help mitigate them?
That's a very important point. The document does address several risks and mitigation strategies. First, the cost of GPUs. They're powerful but expensive to run. The mitigation suggested is active management. Monitor cluster usage with auto-termination. Basically, use resources efficiently, shut them down when not needed, optimize jobs. Data privacy is another huge one, especially with sensitive internal data being used for fine-tuning or a reg. The mitigation is strong governance, control access with Unity Catalog, define clear policies, enforce them rigorously, audit
Right,
access.
protecting the source data is key.
Definitely. Then there's model drift. This is where a model that worked great initially starts performing worse over time because the real-world data patterns change. Mitigation. Proactive monitoring and retraining. Use MLflow for monitoring and retraining. Set up alerts for performance degradation and have a process to update the model. And one more that's specific to LLMs, prompt injection. This is where users try to trick the LLM into doing something it shouldn't, maybe revealing sensitive info or generating harmful content by crafting malicious prompts. The mitigation here involves input sanitization and prompt control. Basically, filtering user inputs and potentially having controls or guards around the LLM itself to limit undesirable outputs.
It's really clear that those practical aspects, deployment, security, cost, risks, are just as vital as the core AI capabilities for any enterprise wanting to adopt this seriously. It shows how much goes into not just building the AI, but safely and effectively operating it long term. Well, we have certainly taken a deep dive today into LLM and generative AI enablement on the Databricks Lakehouse. It's fascinating to see how Databricks is aiming to provide this full stack solution, really trying to make it easier for enterprises to build, yes, but also deploy these advanced AI applications securely and manage them effectively at scale, covering that whole journey.
Absolutely. And if we just zoom out for a second, connect this to the bigger picture, this kind of integrated platform, it fundamentally changes how organizations can interact with and leverage their own internal knowledge, their vast stores of data. It really raises an interesting question for everyone listening, I think. What previously unimaginable business applications suddenly become feasible? What becomes possible when an enterprise can securely and scalably talk to all its internal data, generate new insights, automate complex tasks? It's a shift from passively storing data to actively conversing with it. That's the potential transformation here.
A powerful thought to end on. It's truly an exciting space with implications across almost every industry. We certainly hope this deep dive helps you continue exploring this fascinating world of enterprise AI. Thanks for joining us.